Hey guys, tonight we step outside the busy little world of alarms, glowing screens, traffic lights, and half-finished thoughts, and look up into the oldest quiet view any human being has ever known. Above you, the sky opens like dark silk stretched across forever, with points of light scattered so gently it almost feels deliberate, as if the universe arranged them with sleepy care. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, post your location and local time in the comments, because there is something oddly comforting about knowing where in the world you are listening from while all of us share the same sky in different versions. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. The first relaxing fact about deep space is almost too simple, which is probably why it feels so good. Most of the universe is not crowded. It is not noisy. It is not trying to get your attention every 2 seconds like a phone with emotional issues. It is spacious, patient, and unbelievably calm. When you look up at the stars from Earth, it can seem like the sky is full, almost packed with light. But that is mostly because your eyes are stitching tiny distant points onto one dark surface. In reality, the stars are separated by distances so huge they almost stop feeling like distance at all. Even the nearest star beyond the Sun, Proxima Centauri, is more than 4 light-years away. A light-year is not a measure of time, even though it sounds like one of those terms astronomers invented specifically to be annoying. It is a measure of distance, the distance light travels in 1 year. Light moves so fast that it can circle Earth more than 7 times in a single second, and even with that absurd speed, it still takes over 4 years to reach us from Proxima Centauri. So the nearest neighboring star is not just far away, it is deeply, quietly far away. That means when you stand under the night sky, you are not looking at a ceiling dotted with nearby lamps. You are looking across enormous rooms of darkness, each star resting in its own wide sea of space. There is something soothing about that. The universe is not pressing in on you. It is opening away from you in every direction. And the light itself arrives softly. Starlight does not rush. It crosses those impossible distances with total calm, moving steadily through emptiness for years, sometimes decades, sometimes centuries, before it touches your eyes for a tiny fraction of a second. A star you notice tonight may be sending you light that began its journey before you made some important decision, before you met certain people, before entire trends rose and collapsed in embarrassment. Deep space is wonderfully unconcerned with urgency. You can feel that in the way the sky behaves. Nothing up there seems hurried. The stars do move, of course. Everything in space moves. Earth turns, Earth orbits the Sun orbits the center of the Milky Way, and the galaxy itself is moving too. But the motion is so smooth, so measured, that to you it feels almost still. That is one of the most beautiful tricks in astronomy. Very fast things can look peaceful when the scale is large enough. Deep space is full of motion without fuss. Even darkness itself is not really empty in the way people sometimes imagine. When you look into a dark patch between stars, it can seem like nothing is there. But that darkness is often filled with very thin gas, drifting dust, wandering atoms, invisible radiation, magnetic fields, and the faint leftovers of ancient events. Space is not a blank. It is more like a quiet room where the details reveal themselves only if you stay long enough. Keep that image nearby, because it matters more the farther out we go. Another comforting fact is that your eyes are doing something ancient and intimate when they adjust to the night. Human beings evolved under stars. For most of history, people lived with real darkness, and when night arrived, the sky became one of the main things to look at. There is a reason starlight can feel emotionally familiar even when the science behind it is vast and strange. Your species has been living under this slow lantern show for a very long time. Long before cities blurred the heavens with electric glow, people knew the sky as a companion. The names changed, the myths changed, the measurements improved, but the feeling of standing still and looking up remained almost the same. And the stars themselves are not all alike. which is another gentle surprise. Some are hotter and bluer, some cooler and redder, some brighter, some faint enough that you only notice them when you stop trying too hard. Color in the night sky is subtle to the eye, but it is real. A blue-white star is usually hotter at its surface than a reddish one. So even without hearing a single word, the sky is already giving you information in a quiet visual language. Temperature, size, age, distance, all of it folded into small, steady lights. The same goes for brightness. A star may look bright because it is truly luminous, pouring out an enormous amount of energy, or because it is relatively close to us, cosmically speaking, which is still often hilariously far. A dim star may be faint by nature, or it may simply be much farther away. So from the ground, every point of light is a little mystery, not a stressful mystery, a comfortable one, the kind that invites you in rather than demanding an answer. Then there is the simple miracle that you can see anything at all. Space is mostly transparent. Light can travel through it for incredible distances without being completely blocked. That is why astronomy works. The universe, despite all its scale and complexity, allows itself to be seen. Not fully, of course. It keeps plenty to itself, which is rude, honestly, but also beautiful. Still, it gives you enough. A little starlight, a pale band of the Milky Way if the sky is dark enough. A bright planet holding steady while stars flicker around it. That is an astonishing level of cooperation from something 13.8 billion years old. And while stars may seem eternal from a human point of view, they are changing too. They are born, they shine, they age. But those lives stretch across spans of time so large that even the short-lived stars last millions of years, and many stars live for billions. So when you look at them, you are meeting things that measure existence in a slower rhythm than almost anything in your daily life. They are not worried about deadlines. They are not impressed by urgency. They are simply there, glowing because gravity pulls inward while hot pressure pushes outward, holding a balance that can last longer than entire worlds of history. That balance is one of the calmest ideas in deep space. A star is not just burning like a campfire. It is a huge sphere of gas held together by gravity, with nuclear fusion in its core turning hydrogen into helium and releasing energy. The outward flow of that energy keeps the star from collapsing further. So a star, in a sense, is a long-lasting agreement between weight and light. It is structure made from tension, but not frantic tension. Stable tension. Elegant tension. The kind that creates warmth across impossible distances. You can already feel the journey widening. The familiar night sky is only the front porch of deep space. Behind those visible lights are larger patterns, clouds of dust, entire stellar neighborhoods, and distances that begin to bend your sense of scale into something softer and stranger. But it helps to begin here, close to home, with the oldest view. A dark sky, a turning planet, ancient light arriving right on time by being in no hurry at all. And maybe that is why deep space can be so relaxing. It reminds you that reality is allowed to be immense without becoming chaotic. It can be quiet without being empty. It can be mysterious without being threatening. Above you, the stars hold their places with calm dignity, and between them lies a darkness so broad and gentle that it feels less like absence and more like rest. Soon that darkness will start to show its hidden shapes, and the sky you thought you knew will open into something even deeper. That deeper view begins with a soft, pale band that many people have never fully seen with their own eyes. If you get far enough from city lights on a clear night, the Milky Way stretches overhead like a faint river of light, powdered across the dark in such a delicate way that it almost seems accidental. It is one of the gentlest sights in astronomy, not flashy, not trying too hard. Just a long spill of starlight, quiet and old, crossing the sky with the confidence of something that has been there long before anyone thought to give it a name. What you are seeing in that moment is home, only from the inside. The Milky Way is the galaxy that contains the sun, the planets, the dust, the gas, and the scattered lights of the night sky that felt so distant a moment ago. It is not a small structure. It is vast enough that the numbers begin to lose their edges, so it helps to picture it less like a statistic and more like a landscape. Imagine a great flattened city of stars, with bright neighborhoods, dim outskirts, drifting clouds, and long lanes of shadow running through the glow. Then make it far larger than imagination prefers. That gets you a little closer. From the outside, the Milky Way is a spiral galaxy, shaped with broad, curving arms that wind outward from a bright central region. From the inside, where you happen to be, it does not look like a pinwheel at all. It looks like a band because you are embedded within its disk, tucked into one of its quieter suburban addresses, not too near the center, not flung too far into the edge. The Sun lives in a small spiral feature called the Orion Arm, or Orion Spur, which is less a grand boulevard and more a pleasant side street by galactic standards. Very nice neighborhood, reasonable starlight, good long-term parking if you are a comet. That simple fact is deeply calming. You are not standing outside the galaxy trying to make sense of it from a distance. You are already in it, carried along inside its structure without needing to do anything at all. The Milky Way is not something above you. It is something around you. When the bright band crosses the sky, your eyes are tracing the dense plane of the galaxy where many of its stars are concentrated. Looking along that plane means looking through a thicker crowd of stars, which is why the Milky Way appears brighter there than in other directions. You are peering through the disk, through layer after layer of stellar light, like looking across a glowing city from within rather than staring at one building. The beauty of it comes partly from that crowding, and partly from the fact that even a crowded galaxy still leaves room for immense quiet between things. It is easy to think of a galaxy as neatly filled, but the truth is gentler. Even within the Milky Way, stars are separated by huge distances. The galaxy holds hundreds of billions of stars, yet it is still mostly space. So when you picture the spiral arms, it helps not to imagine packed traffic, but loose, graceful groupings, like fireflies spread across a continent-sized garden. The arms are not solid lines. They are patterns, regions where stars and gas are more concentrated, moving in a long cosmic flow. That flow matters. A spiral arm is not a fixed object in the way a road is fixed. It is more like a traffic pattern or a wave moving through a crowd. Stars orbit the galactic center, and the arms reflect regions where matter bunches more densely for long periods. Gas enters these denser regions, gets compressed, and helps form new stars. So the Milky Way is not frozen. It is organized motion. A slow, enormous choreography that only looks still, because the dance takes millions of years to make an obvious move. And then there are the dust lanes, those dark seams that thread through the bright band. They are one of the loveliest details once you know what they are. Dust in space is not like the dust on a bookshelf, though both can be mildly judgmental if ignored. Cosmic dust is made of tiny solid particles, often containing carbon or silicate material, mixed into the thin gas between stars. When that dust lies between you and bright stellar regions, it blocks or dims the light behind it. That creates those dark ribbons and patches in the Milky Way, not because nothing is there, but because something very delicate is standing in the way. So even the dark marks in the galaxy are part of its beauty. They are not tears in the sky. They are clouds, soft obstacles, places where future stars may one day form. Remember that quiet little detail, because the places that seem darkest in space often turn out to be the places where something is slowly beginning. If you could rise far above the disk of the Milky Way and look down, you would see a barred spiral galaxy. The central region is crossed by a bar-shaped structure of stars, and from that inner area, the spiral arms curve outward. The whole galaxy spans roughly 100,000 light-years from side to side, which is one of those distances that politely refuses to fit into normal thought. Light, moving faster than anything else we know, would still need about 100,000 years to travel from one side of our galaxy to the other. So when you look at the Milky Way, you are not just seeing home. You are seeing a home so wide that light itself takes ages to cross it. And yet it holds together. Gravity is the quiet architect here. It gathers stars into orbits, shapes gas into clouds, keeps clusters bound, and helps the entire galaxy maintain its form over immense spans of time. Not perfect form, of course. Galaxies evolve. They interact. They grow, bend, and change. The Milky Way has likely absorbed smaller galaxies in the past, and it is still surrounded by little satellite galaxies drifting nearby. But the overall impression remains one of remarkable stability. A structure this large might sound like it should feel unruly. Instead, it feels composed, almost stately, as if the galaxy has no interest in rushing through its own life. Your own star is part of that slow movement. The Sun orbits the center of the Milky Way at an astonishing speed, yet because the path is so large, one full orbit takes about 230 million years. That means since the age of the dinosaurs, the Sun has only completed a little more than one trip around the galaxy. You and everything you know are riding on that long arc right now, carried through deep space in total silence. No sensation, no engine noise, no announcement from the captain. Just a steady glide through the dark. There is something wonderfully relaxing about realizing that your ordinary life unfolds inside motions this large. Morning coffee, unread messages, plants on windowsills, all of it happening aboard a world that circles a star that circles a galactic center that glows behind veils of dust. The scale does not erase the smallness of life. It softens it. It gives it room to breathe. Toward the center of the Milky Way, the stars become more densely packed and the glow grows richer. Hidden there is Sagittarius, a backslash, the supermassive black hole at the heart of our galaxy. It sounds dramatic, and in a way it is, but what feels oddly peaceful is that the galaxy does not behave like it is in crisis about this. The stars continue their long orbits. The disk holds its shape. The dust drifts. Even the most mysterious object at the center is simply part of the structure, one note in a much larger piece of music. And overhead, if the night is dark enough, all of this reduces itself into that same pale river of light. A galaxy can be 100,000 light-years wide and still arrive to you as a soft band across the sky. That contrast is part of the magic. The grandest things often appear with the least noise. Soon the galaxy's quieter spaces will open more fully, and the seeming emptiness between stars will begin to show its own secret texture. For now, it is enough to feel the shape of the Milky Way around you. Spiral, dusty, luminous, slow and steady, carrying you through the dark with the kind of patience only a galaxy can afford. The Milky Way has a way of making the sky feel full, but the deeper truth is softer than that. Between those bright lanes and scattered points of light, there is an enormous amount of space. Real space. Wide, cold, almost impossibly open. And one of the most relaxing facts about deep space is that this openness is not a flaw in the picture. It is the picture. The universe is built with room in it. If you could drift away from the nearest stars and pause in the regions between them, the first thing you might notice is how little there is to notice in the usual sense. No glowing signs, no grand cosmic soundtrack, no tidy borders telling you where one place ends and another begins. Just distance, held quietly in all directions. It would feel less like being surrounded by objects and more like resting inside a vast pause. That emptiness is often called interstellar space, the space between stars, and even though it sounds like nothing at all, it is not truly empty. It contains gas, mostly hydrogen with a little helium and traces of heavier elements mixed in. There are tiny grains of dust. There are magnetic fields. There are fast-moving particles called cosmic rays. There is starlight passing through. There is heat, though usually very little. There are waves and shock fronts and slow chemical changes unfolding over ages. It is a very light kind of fullness, so light that on Earth it would feel almost like absence, but in deep space it matters. The gas between stars is astonishingly thin, much thinner than any vacuum you could easily make on Earth. In many regions, you might find only a few atoms in a cubic centimeter, sometimes fewer. That means a volume of space the size of a sugar cube could contain almost nothing at all, just a handful of wandering particles with huge stretches of emptiness between them. And still, Over distances of many light years, even that faint material adds up. A whisper repeated across a cathedral eventually becomes a presence. This is one of the great calming patterns in astronomy. Tiny things spread over immense distances can shape the universe in beautiful ways. You do not need density for meaning. You do not need noise for structure. Space can be thin and still be important. The dust is especially lovely once you understand what it does. These grains are extremely small, smaller than ordinary household dust, but they interact with light in ways that help paint the galaxy. They block some visible light, scatter some of it, and glow in infrared when warmed. Because of that, dust clouds can hide stars behind them, soften bright regions, and create those dark lanes you noticed in the Milky Way. They can also help cool clouds of gas, which turns out to matter a great deal when stars begin to form. So the soft haze between stars is not just decoration. It is part of the machinery of creation, though machinery feels like far too harsh a word for something this elegant. There is also a kind of deep politeness to interstellar space. It rarely crowds anything. Even in a galaxy with hundreds of billions of stars, most regions are mostly open. If the sun were the size of a small coin, the nearest star on that scale would still be many hundreds of kilometers away. That is how much space there is between stars. They are not packed together like city lights. They are more like lanterns placed across a continent, each one with a great dark field around it. And that darkness is not dead, it is simply quiet. When astronomers study interstellar space, they are often studying matter in a very patient state. Gas drifting for millions of years, dust slowly gathering, atoms meeting, separating, cooling, and moving on. In colder, denser clouds, simple molecules can form, including water, ammonia, and carbon-based compounds. Not in cozy, Earth-like conditions, of course. Deep space is still deep space, and it likes to keep things difficult in a graceful sort of way. But chemistry does happen there. Even in the dark, matter remains busy in its slow, polite fashion. Some parts of interstellar space are warmer than others. Some are filled with gas heated by nearby stars. Some are cooler and denser, almost hidden from view. Some are shaped by the remains of stellar explosions that sent waves rippling outward long ago. This means the space between stars is not one single environment. It is more like weather spread across light years, with regions that differ in temperature, density, and motion. But it all changes slowly, so slowly that the overall feeling remains calm. That calm is one reason space sounds so silent in the imagination. Strictly speaking, sound as you know it cannot travel through most of space because sound needs matter packed closely enough to pass vibrations along. Air does that beautifully. Water does it even better. Interstellar space is usually far too thin. So if you were floating there, you would not hear the deep hum of galaxies or the whisper of stars in the way films sometimes promise. You would be held in something closer to true silence. There is something deeply comforting about that. The universe is full of energy, motion, and radiation, yet much of it unfolds without any audible demand at all. Stars burn, clouds drift, particles race through darkness. Entire systems move through the galaxy, and still silence holds. Of course, silence in space does not mean inactivity. Light is everywhere. Radiation from stars travels outward across the dark. Ultraviolet light can strip electrons from atoms in nearby gas, creating glowing regions around hot young stars. X-rays and gamma rays pass through space from more extreme events. Radio waves cross huge distances and can be collected by careful instruments here on Earth. So the emptiness between stars is filled with messages. Only most of them are not messages your ears can hear. Space is quiet, but not mute. That difference matters. It reminds you that absence is not always emptiness. A dark room can still be full of warmth. A pause in music can still carry emotion. Interstellar space can look blank and still be rich with structure, motion, and hidden light. Even the temperature of deep space has its own strange gentleness. Far from stars, the background temperature of the universe is only a few degrees above absolute zero. That sounds severe, and in a practical sense it is, but it also gives deep space a kind of stillness. Heat is energy in motion, atoms jostling and colliding, but in the great dark between the stars, there is often so little matter and so little warmth that everything feels held in suspension. Not frozen like a dramatic winter scene, more like a breath that has lasted for ages. And yet within this thin and silent medium, the next stars are already being prepared. That is the quiet little detail worth keeping close. The emptiness between stars is where future stars begin. Gas clouds can gather and cool. Gravity can slowly draw matter inward. Dust can help shield and shape those regions. Over immense spans of time, the gentle becomes decisive. A cloud thickens. A core forms. A new light waits inside darkness. So the space between stars is not just a gap to cross on the way to more interesting things. It is one of the interesting things. It is the calm fabric that makes the brighter parts possible. It gives the galaxy its softness, its depth, its sense of breathing room. Without it, the sky would lose that strange balance between presence and openness that makes it feel so restorative. Soon the dark will thicken into visible clouds, and those thin traces of gas and dust will gather into shapes so beautiful they almost seem painted. For the moment, it is enough to rest here in the wide hush between stars, where almost nothing is crowded, almost everything is patient, and silence is not the absence of life, but the way deep space carries it. The first time you see a nebula in a telescope image, it can feel almost unfair. Space has already given you stars, distance, silence, and the Milky Way spread across the dark, and then it casually reveals these enormous clouds that look as if someone exhaled color into the universe and left it there to glow. Soft reds, blue-green veils, folds of violet shadow, long curtains of dust, bright rims where starlight brushes the edges. The whole thing can seem too graceful to be real, which is a very classic space move. Deep space does this often. It stays quiet for a while, then shows you something so beautiful you forgive it for being impossible to visit before bedtime. A nebula is a cloud of gas and dust in space. That is the plain description, and it is accurate, but it does not quite prepare you for the feeling of one. Some are places where stars are being born. Some are shells of material cast off by dying stars. Some are dark clouds that hide the light behind them. Some shine because nearby stars energize their gas and make it glow. The word covers several kinds of cosmic cloud, but the mood they share is unmistakable. They make the universe feel soft around the edges. That softness is real in a physical sense too. Nebulas are made of incredibly thin material. Even the denser regions of a star-forming nebula would seem emptier than the best vacuums made on Earth. And yet when you spread that little bit of matter across many trillions of kilometers, it becomes a structure large enough to cradle whole generations of stars. Space is very good at turning the nearly invisible into the unforgettable. The colors in nebula images come from a few different sources, and once you know that, the glow becomes even gentler. In emission nebulae, hot young stars pour out ultraviolet light that excites the gas around them. When the atoms in that gas relax again, they release light at specific colors. Hydrogen often glows red. Oxygen can shine with a blue-green tint. Sulfur can appear reddish as well, depending on the image and how it is processed. Some of those colors are emphasized in photographs to help reveal structure, but the underlying light is real. The cloud is genuinely responding to starlight. It is illuminated from within and around, like a slow cosmic lantern. Reflection nebulae behave a little differently. They do not glow mainly because the gas is energized. They shine because dust scatters the light of nearby stars. Blue light scatters especially well, which is why some reflection nebulae have that pale, cool glow, almost like moonlight caught in smoke. The effect feels delicate because it is delicate. Tiny grains of dust, thin beams of starlight, immense distances, and all of it meeting in silence. Then there are dark nebulae, which may be the most soothing of all once you understand them. They are dense enough to block light from stars behind them, so they appear as silhouettes against brighter regions. At first glance, they can look like missing pieces of the sky, but they are not empty. They are full of gas, full of dust, full of hidden interiors where gravity is quietly at work. A dark nebula is one of the best reminders that in deep space, the places that seem blank are often the places where something patient is underway. Inside those colder, denser clouds, gravity begins its long, careful work. A nebula does not rush into making stars, it gathers itself. Small variations in density can grow over time. A region with slightly more matter has slightly more gravity, which helps pull in more matter, which deepens the process. Slowly, unevenly, softly, a cloud can begin to fragment into clumps. Those clumps continue to contract. Material falls inward. Pressure builds. Temperature rises. After enough time, a protostar forms inside the cloud, still wrapped in gas and dust, hidden from ordinary view. That is one of the loveliest facts in astronomy. A star begins in concealment. Before it shines clearly across the dark, it spends a long time inside a cloud, gathering itself in private. The future brightness is prepared inside shadow. Some of the most famous nebula images show towering pillars and sculpted ridges, shapes that look almost carved. They are not carved by hands, of course, but by light, radiation, winds from nearby stars, and differences in density within the cloud itself. The pillars of creation in the Eagle Nebula are a good example. They look monumental, almost architectural, but they are also temporary on cosmic timescales. Radiation from nearby hot stars erodes and reshapes them over time. So even these giant structures are part of a slow flow. Nebulas are less like static monuments and more like weather systems with magnificent patience. The Orion Nebula is another beautiful case, and it has a special tenderness because it is one of the closest large star-forming regions to Earth. In dark conditions, people can glimpse it as a faint fuzzy patch in the sword of Orion. Through telescopes and long exposures, it opens into a luminous region where young stars are actively forming. You are looking at a nursery in space, a place where gravity, gas, radiation, and time are all meeting to build new suns. There is something quietly comforting in that. The universe is not only aging, it is also still making things. And it has been making things this way for a very long time. Stars form in molecular clouds, the coldest and densest parts of interstellar space, where atoms have joined into molecules, especially molecular hydrogen. These clouds can stretch across dozens or even hundreds of light years. Within them, the light is dim, the temperatures are low, and chemistry unfolds gently on dust grains and in shadowed gas. The environment is sparse by earthly standards, but perfect for slow assembly. It is one of the reasons deep space feels so restorative when you think about it carefully. Creation there is rarely frantic. It is gradual, layered, and almost polite. As young stars appear, they begin to change the clouds around them. Their light ionizes gas. Their stellar winds push material outward. Jets from forming stars can punch narrow streams into surrounding matter. Over time, the very stars born from a nebula help sculpt, brighten, and disperse it. This means a nebula can be both cradle and undoing, birthplace and transformation. The cloud gathers matter into stars, and the stars in turn reshape the cloud. There is no sharp line where one phase stops and another begins. It is all one long unfolding. That is part of what makes nebulae so easy to sink into mentally. They do not feel mechanical. They feel alive in the broad cosmic sense, full of change without hurry. You can picture light moving through them, dust casting soft shadows, gravity drawing inward, pockets of gas collapsing, new stars warming their surroundings. It is a dynamic scene, but one that unfolds over spans so long the overall impression remains calm. Nothing is lunging. Nothing is clamoring. Everything is becoming. Even their scale adds to the piece. A glowing cloud can stretch for light years, sometimes for dozens of light years, and still be only one region within a galaxy. That gives a strange kind of emotional relief. The universe allows beauty to be enormous. It does not keep its finest structures small and fragile. It lets them bloom across distances so wide that light takes years just to cross one glowing edge to another. And inside those clouds, among the folds and shadows, Worlds are waiting in the far future. Stars will stabilize. Disks of material around young stars may gather into planets, moons, comets, dust belts. The process is still hidden when the nebula is doing its earliest work, but the possibility is there from the beginning. A cloud of gas and dust can eventually become a system with sunlight, seasons, oceans, or stranger things beneath stranger skies. So when you see a nebula, you are seeing deep space in one of its most tender moods. Matter has not yet settled into the clear certainty of stars and planets. It is still suspended, glowing, drifting, collapsing, reflecting, concealing. It is the universe in the middle of a thought, and that thought is full of light. Soon those young stars will lead farther outward into the long, calm lives they keep for millions or billions of years. But for a little while longer, it is enough to stay with the clouds, breathing their color in the dark. From those glowing clouds, the stars finally emerge into clearer view, and what feels especially comforting is how long they tend to remain themselves. A star may begin in secrecy, wrapped in gas and dust, but once it settles into a stable life, it often stays there for an astonishing stretch of time. Deep space, for all its mystery, is full of things that endure, and stars are among the calmest examples of that endurance. A star becomes truly steady when the pressure from fusion in its core balances the inward pull of gravity. That balance matters more than almost anything else in stellar life. Gravity is always trying to draw the star inward. Fusion is always pushing energy outward. When those two influences meet in a long, stable agreement, the star enters what astronomers call the main sequence, which sounds oddly bureaucratic for something so beautiful, but the idea itself is simple. This is the long middle life of a star, the phase in which it shines with the most reliable patience. Our sun is in that phase right now, and has been for billions of years. It is not racing through its existence. It is taking its time, converting hydrogen into helium in its core with a steadiness that makes life on Earth possible. Every sunrise you have ever seen has depended on that stability. The warmth on skin, the light on leaves, the changing color of a room in the morning, all of it comes from a star quietly maintaining balance across immense time. That is one of the most relaxing truths in astronomy. The everyday comfort of sunlight is connected to one of the deepest patterns in the universe. A star is stable because gravity and fusion are holding each other in check, almost politely, over spans so long that human history barely registers as a flicker. The length of a star's life depends mostly on its mass, and this is where deep space becomes gently surprising again. You might expect a larger star to live longer because it has more fuel, but massive stars also burn that fuel much faster. They are brighter, hotter, and more extravagant with their energy. Smaller stars, especially red dwarfs, are slower and more economical. They sip their fuel. They glow modestly. They are in no hurry at all. Some of them may live for trillions of years, far longer than the current age of the universe, which means the cosmos has not existed long enough yet for even the oldest red dwarfs to finish their full lives. They are still going, and they will keep going long after stars like the sun are gone. There is something very soothing about that quiet endurance. A small red dwarf may not dominate the sky in the way a brilliant blue-white star does, but it has a kind of cosmic wisdom. It lasts. It keeps its light. It stays with the dark for ages beyond easy imagination. Stars like the sun live shorter lives than red dwarfs, but even then, short is a generous exaggeration. The sun's total lifetime will be around 10 billion years. It formed about 4.6 billion years ago, so it is somewhere in its calm middle age, still very much engaged in the same essential process that has sustained it for eons. That means when you think of the sun, you are not thinking of something fragile or temporary in any ordinary sense. You are thinking of a star with a lifespan so broad that mountains rise and wear away beneath it, while it simply continues to shine. And stars are not all equal in color or mood. The hotter ones burn with a bluish or white light, while cooler stars lean toward orange and red. The color is not decoration. It tells you about surface temperature. A blue star is usually hotter than a red one, a white star hotter than a golden one. So the night sky is full of stars quietly revealing their nature through hue alone, each one like a note held at a slightly different pitch. Even their brightness has layers of meaning. Some stars appear brilliant because they are intrinsically powerful, pouring out vast amounts of energy. Others shine brightly because they are closer to us. A few are both luminous and relatively nearby, which is very considerate of them, honestly. But every bright star you see is a combination of real output and distance, and that means every point of light carries information about how much energy is being released far away in the dark. Much of that energy comes from the core, where fusion happens under immense pressure and heat. Hydrogen nuclei combine to form helium, and in the process a small amount of mass is converted into energy. That energy moves outward, but not always quickly. In stars like the Sun, a photon created in the core does not simply fly straight to the surface. It can spend an extraordinary amount of time being absorbed and re-emitted, bouncing through dense layers in a staggeringly slow journey. The light that finally leaves the Sun's surface and reaches Earth in about 8 minutes may represent energy that took thousands or even hundreds of thousands of years to work its way outward from the core. So even starlight can have a long interior history before it ever enters space. Keep that image nearby, because it adds another layer to the quiet patience of stars. Light itself may have waited inside the star before continuing on to you. The surfaces of stars are not still, even if the stars themselves feel steady. Hot gas rises and cool gas sinks. Magnetic fields twist and reconnect. Some stars flare, some pulse, some rotate quickly, some slowly. There is activity there, texture and motion and weather of a kind, but from far away the overall impression remains peaceful. It is similar to watching the sea from a cliff at dusk. You know there is movement, waves and currents and restless detail, but from that distance the surface reads as calm. There are also stars that live together. Many stars are part of binary or multiple star systems, orbiting a shared center of mass. So the lonely single star is not the only model. In fact, companionship may be quite common among stars. Some pairs are widely separated and gentle in their orbit. Others are close enough to influence each other more strongly. The sky, which can seem scattered and solitary, often contains relationships hidden in the dark. And this is where stellar life begins to feel even more beautiful. A star is not just a glowing object. It is a long event, a structure of gas held in balance, shaped by gravity, powered by fusion, radiating energy into surrounding space for millions, billions, or even trillions of years. It lights dust clouds, warms planets, shapes the chemistry of nearby material, and gives future worlds a chance to form and evolve. Its influence travels far beyond its visible edge. The Sun is a perfect example of this calm generosity. It contains almost all the mass in our solar system, and its gravity keeps the planets in orbit. Its light drives weather, climate, photosynthesis, and the basic rhythms of life on Earth. Yet in astronomical terms, the Sun is not unusual in any dramatic way. It is a fairly ordinary star, which may be one of the loveliest facts of all. The kind of star that can sustain oceans, seasons, and living things is not some rare cosmic jewel hidden in one lucky corner. It is part of the universe's normal vocabulary. That ordinary greatness changes the feeling of the night sky. Every steady star becomes more than a pretty point. It becomes a possible center, a place where worlds may circle, a source of long-lasting warmth, a keeper of time on scales that make human anxiety seem a little less sharp around the edges. Eventually, stars do change. Their fuel shifts, their cores evolve, their outer layers respond. But the important feeling here is not one of ending, it is one of duration. A star spends most of its existence simply being a star, holding itself together through a balance so elegant that it can persist almost beyond belief. The clouds we passed earlier were full of becoming. Here, among mature stars, deep space offers another gift: continuity. And soon that continuity will widen again, because around many of these stars, In the faint dark beyond the glare, whole worlds are moving in quiet circles, unseen for most of human history, waiting to be noticed at last. Around many of those steady stars, worlds are circling in the dark. That idea alone can soften the mind for a while. For most of human history, people could only guess whether other stars had planets. It was a beautiful suspicion, more philosophy than measurement, a quiet hope resting in the night. And then, very gradually, modern astronomy began to confirm it. Not with drama, not with some giant curtain rising over a cosmic stage, but with patient little signals. A star dimming by the smallest amount, a faint wobble in its motion. Tiny shifts in light that whispered the same message again and again. There are worlds out there, many of them. Exoplanets, planets beyond our solar system, turned out not to be rare decorations added to a few fortunate stars. They seem to be common. The galaxy may be full of them, possibly numbering in the hundreds of billions. Some stars may have one planet, some have several. Some host tightly packed systems with worlds moving in close orbits. Some likely have distant icy giants and dark outer belts. It seems the universe did not stop with one little arrangement of sun and planets and call it a day. It kept going, quietly, generously making more. And what feels especially calming is how these worlds were found. Not by racing out to visit them, not by grabbing sharp images of alien landscapes right away, but by learning to notice gentleness. One of the main methods is the transit method, where a planet passes in front of its star from our point of view and blocks a tiny fraction of the light. That dip can be incredibly small, almost absurdly small, and yet sensitive instruments can detect it. So entire planets announce themselves not with noise, but with a soft dimming. A world enters the story by making its star just slightly less bright for a little while. There is something lovely about that, discovery by patience, knowledge arriving because someone watched carefully enough. Another method measures the way a star wobbles under the pull of an orbiting planet. The planet is not simply circling the star while the star sits perfectly still. Both orbit a shared center of mass, though the star moves much less because it is so much more massive. That slight motion can shift the star's light in measurable ways. Again, the signal is delicate. A tug, a rhythm, a star moving just enough to reveal that something unseen is keeping it company. So many of these distant worlds first entered human awareness as patterns, almost like hints in music. A repeated dimming, a repeated sway, a small regularity in light. It suits deep space perfectly. The hidden things tend to reveal themselves softly. And the worlds themselves are far stranger and more varied than early imagination sometimes allowed. Some are gas giants larger than Jupiter, orbiting close to their stars where they race through a year in just a few days. Those were among the first easy-to-detect exoplanets because they make big, obvious signals, relatively speaking. They were surprising at first, these so-called hot Jupiters, because they did not resemble the tidy arrangement of our own solar system. But the universe has never shown much interest in arranging itself mainly for our convenience. It prefers variety. Other exoplanets are rocky, more like Earth in size, though not necessarily in mood. Some may be scorched under intense sunlight. Some may be frozen in outer darkness. Some likely have thick atmospheres rich in gases that would feel deeply unfriendly to your lungs, which is rude, honestly, but also very on brand for space. Some may have oceans. Some may have clouds of mineral vapor. Some may be locked so that one side always faces the star while the other remains in endless night, leaving a perpetual twilight ring between extremes. Even that sounds strangely peaceful when you picture it gently enough. A world where sunrise never moves. A world where the same stars always hang above the dark side sky. There are planets called super-Earths, larger than Earth but smaller than Neptune, and mini-Neptunes, wrapped in thicker gaseous envelopes. Our own solar system does not contain an exact example of either category, which means some of the most common kinds of planets in the galaxy are ones we do not have at home. That is a beautiful little cosmic reminder that familiarity is not the same thing as normal. The universe has more design options than one neighborhood can show you. Some of the most soothing exoplanet systems are the compact ones, where several planets orbit the same star in close, regular patterns. The TRAPPIST-1 system is a famous example. It contains 7 Earth-sized planets orbiting a cool red dwarf star. Their orbits are tight, their years short, and several lie in the region where temperatures might allow liquid water under the right conditions. No one knows exactly what those surfaces are like. They remain mostly hidden from us. But the system itself already feels calm to imagine. Several rocky worlds moving in close harmony around a dim red sun, each one carrying its own weather, its own horizon, its own long night. That dim red sun matters too. Red dwarfs are cooler and fainter than the sun, which means the habitable zone, the range of distances where liquid water could exist on a planet's surface under suitable conditions, lies much closer in. A planet can orbit very near such a star and still receive only moderate warmth. So the architecture of comfort changes from system to system. What would be far too hot around one star might be perfectly mild around another. Habitability, like so much in astronomy, depends on context. And that word, habitable, is worth holding carefully. It does not mean inhabited. It does not promise forests or oceans or anything waiting politely for postcards. It usually means the conditions might allow liquid water, at least in principle, if the atmosphere and other factors cooperate. It is a modest word doing quite a lot of emotional work. Still, even modest possibility has power. It means some worlds may sit in the right thermal balance, neither too hot nor too cold, with starlight arriving at a level that allows interesting chemistry and perhaps stable climates. The image is enough. A rocky planet under a quiet sky, circling a distant sun in the great dark. Even the atmospheres of some exoplanets are beginning to reveal themselves. When a planet transits its star, a tiny bit of starlight can pass through the planet's atmosphere first. Different gases absorb different wavelengths of light, so astronomers can sometimes infer the presence of water vapor, sodium, carbon dioxide, methane, or other compounds. This is an extraordinary thing when you stop to feel it properly. Light leaves a star, crosses space, filters through the sky of another world, continues across more space, and is finally read by instruments built on one small planet around one ordinary star. The chain is so delicate, and yet it works. That means deep space is not just full of hidden worlds. It is beginning to let us sense the air above them. And then there are the worlds that may never be comfortable by human standards and still feel mesmerizing. Planets where it rains molten glass sideways in fierce winds. Planets so dark they reflect almost no light. Puffy planets with densities so low they seem almost absurd. Lava worlds, ocean worlds, giant worlds heated from within, perhaps even rogue planets drifting without any star at all. Rogue planets are especially haunting in a peaceful way. A world untethered from sunlight, traveling through interstellar darkness with only internal warmth, maybe carrying a thick atmosphere or subsurface ocean, moving through the galaxy almost anonymously. Even deep space has wanderers. All of this changes the feeling of the night sky. The stars above you are no longer just stars. Many are likely centers of systems. Around them, unseen from the ground, planets may be passing through dawn, crossing cloud shadows, turning their nights toward cold constellations, holding winds in motion across seas or plains or stranger landscapes with no earthly names. The galaxy becomes more intimate that way. Not smaller, not less mysterious, but more inhabited by possibility. And soon that possibility widens again, because stars and their planets are only part of the story. Beyond them, the galaxy gives way to other galaxies, each carrying billions more stars, billions more chances for worlds, all of them drifting across the wider dark like lanterns on a sea too large to measure in one glance. Beyond the stars and their hidden worlds, the scale opens again so gently that you almost do not notice the moment it happens. One instant you are thinking about planets moving around distant suns, little systems folded into the Milky Way like private thoughts, and then the view widens until even a galaxy begins to feel like a single floating thing. A whole city of stars becomes one soft shape in the dark. That shift in scale is one of the most calming experiences in astronomy. Deep space keeps showing you that whatever felt enormous a moment ago can still belong to something larger, quieter, and somehow even more graceful. A galaxy from far away often looks less like a machine and more like a lantern. A spiral galaxy glows with a central brightness and sweeping arms, a hazy structure suspended in blackness. An elliptical galaxy appears rounder or more stretched, smoother and softer, like old gold light gathered into a single luminous cloud. Irregular galaxies look looser, less symmetrical, a little more untamed but still gentle at this scale, like fragments of starlight drifting into their own shape. Seen across millions of light years, even the grandest galaxies carry themselves with remarkable calm. And there are so many of them. For a long time, people were not sure what those faint spiral smudges in the sky really were. Some thought they might be clouds or smaller structures within the Milky Way. Then astronomy slowly revealed a more beautiful answer. Many of those dim spirals were not nearby objects at all. They were entire galaxies, separate from our own, each one full of stars. The universe was not just our galaxy with a few decorations around it. It was a much broader expanse filled with island universes, as people once poetically called them, each drifting in the deep. That realization changed the emotional size of reality. It still does. The Andromeda Galaxy is the nearest large spiral galaxy to the Milky Way, and even that nearby description needs a very relaxed definition of near. Its light takes about 2.5 million years to reach Earth. So when you see Andromeda, whether as a faint patch through binoculars or as a sweeping spiral in a photograph, you are seeing light that began traveling toward you long before modern humans had built cities, long before writing, long before almost everything your daily mind considers recent. Deep space always finds these elegant ways of making time itself feel soft around the edges. Andromeda contains roughly 1 trillion stars, perhaps more than the Milky Way, though the exact details are still refined as observations improve. The important feeling is not the number itself, but the gentleness of what it implies. A galaxy can hold hundreds of billions or even 1 trillion stars and still appear in the sky as a quiet blur. Grandeur does not always arrive loudly. Sometimes it arrives as a smudge. Other galaxies stretch farther still, scattered across space in every direction. Some are small dwarf galaxies with far fewer stars. Others are giant ellipticals dominating the centers of clusters. Some are rich in gas and star formation. Others are older, redder, calmer in appearance, their brightest days of star birth mostly behind them. Galaxies, like stars, have personalities shaped by age, mass, history, and environment. Some feel youthful and blue with fresh star formation. Some feel ancient and settled, full of older stars glowing with a warmer tint. Even at this colossal scale, deep space allows variety. Galaxies are not distributed evenly like dots on graph paper. They gather into groups and clusters. The Milky Way belongs to a small gathering called the Local Group, which includes Andromeda, the Triangulum Galaxy, and many smaller dwarf galaxies orbiting the larger ones. It is a quiet little neighborhood by cosmic standards, spacious and modest. Beyond that lie larger clusters with hundreds or thousands of galaxies bound together by gravity. And beyond those, superclusters and long filaments of matter stretching across the universe in patterns, so immense they begin to resemble lace, foam, or the branching of roots through soil. That is one of the strangest and most beautiful facts about the large-scale universe. Galaxies are not only scattered, they are arranged in a vast cosmic web, with filaments and nodes where matter is more concentrated, and great voids in between where galaxies are much rarer. Even the universe on its largest scale seems to favor structure with breathing room. The same pattern keeps returning. Light gathered into shapes, shapes separated by openness, openness carrying its own kind of calm. The voids are especially soothing to imagine. These are enormous regions of space where relatively few galaxies are found. They are not perfectly empty, but they are strikingly sparse. If you were somehow placed inside one, the distant galaxies would seem even farther, the darkness even wider. It is almost too much openness to picture comfortably, and yet there is peace in it too. The universe does not cram everything together. It leaves room for silence on the largest scales it knows how to make. Galaxies themselves move through this immense structure, and sometimes they meet. The word collision can sound harsh, but galactic encounters are usually more graceful than the term suggests. Because the stars inside galaxies are so widely separated, two galaxies can pass through each other without most individual stars crashing directly together. Their shapes distort under gravity. Their gas clouds interact more strongly. Tidal streams stretch outward like glowing silk. Over time, the galaxies may merge into a new form. It is dramatic in the long view, but not frantic. The process can take hundreds of millions or billions of years. Even cosmic upheaval prefers patience. The Milky Way and Andromeda are moving toward each other and are expected to merge billions of years from now. That fact sounds dramatic at first, but the emotional truth is gentler. By the time it happens, the night sky from any surviving worlds would unfold slowly through ages, the shapes of the galaxies growing larger over unimaginable spans. Stars would continue on their paths. Distances between individual stars would still be vast. It would be less like a crash, and more like two immense flocks of light gradually interweaving. Remember that image because it helps correct a common feeling that large events in space must be violent in the human sense. Often they are simply grand. They have scale without panic, motion without noise, change without hurry. At the centers of many large galaxies sit supermassive black holes, including the one in our own galaxy. These central objects can influence the surrounding region in significant ways, especially when matter falls inward and releases huge amounts of energy. Some galaxies become active in this way, with bright cores called active galactic nuclei. Some quasars, powered by feeding supermassive black holes in the early universe, shine with incredible brilliance across cosmic distances. Yet even here, the feeling can remain strangely calm when seen from afar. A bright galactic heart glowing across billions of years, energy released in silence, light crossing the dark like a message that refuses to hurry. The colors of galaxies tell quiet stories too. Younger, hotter stars tend to make regions look bluer. Older stellar populations give galaxies a warmer, redder appearance. Dust can dim and redden the light further, so a galaxy's glow is a kind of memory, a blended record of star formation, age, and structure. When you see an image of a galaxy, you are not just admiring its shape. You are reading a long history written in color and light. And still, despite all this complexity, the emotional impression stays so simple. Galaxies drift, they shine, they gather, they separate. They turn in darkness with the kind of dignity that makes the universe feel less like chaos and more like a slow procession of illuminated forms. The deeper you go, the less deep space feels empty in any cold sense. It feels spacious, yes, but also gently inhabited by pattern. Soon even these galaxies will begin to blur into a stranger idea, because the farther you look, the more you also look back in time. Distance and history start folding into one another out here, and the universe becomes not just a place, but a record of light arriving late on purpose. The farther you go, the gentler time begins to feel. That is one of the quiet surprises waiting out here. Distance in deep space is never only distance. It is also delay. It is history arriving softly. Light moves incredibly fast, fast enough to circle Earth more than 7 times in a second, and yet the universe is so spacious that even light cannot cross it instantly. The sunlight on your skin is already a little old by the time it reaches you, traveling from the sun in about 8 minutes. The glow from Andromeda has been on its way for roughly 2.5 million years. When telescopes reach toward the most distant galaxies, they collect light that has traveled for billions of years, which means looking far away is also looking far back. The universe does not show you everything as it is right now. It shows you everything on a graceful delay, as if reality itself prefers to speak in echoes. That changes the feeling of the night sky in a beautiful way. A star is not only a star, it is a memory in motion. A galaxy is not only a place, it is a scene from long ago still making its way toward you through the dark. When astronomers point a telescope into deeper and deeper space, they are not just making the universe feel larger. They are uncovering earlier chapters of the same story. Nearby objects show the more recent universe. More distant ones show it at younger ages. Go far enough and the galaxies begin to look less settled, less mature, more like early drafts of the structures we know now. So deep space is not arranged like a museum with labels on the wall. It is arranged in layers of light-travel time. Distance becomes a kind of archive. The dark between galaxies is full of old messages, still intact, still crossing the silence with no sense of hurry at all. And light, for all its speed, is strangely patient. Once it leaves a star or a galaxy, it keeps going unless something blocks it, absorbs it, or bends its path. It does not get bored. It does not lose interest halfway through intergalactic space and wander off emotionally. It simply travels. This is why astronomy works so beautifully. The universe allows its past to remain visible. A telescope does not need to dig into stone or dust to study ancient history. It only has to collect the light that has been taking its time. Even the earliest galaxies we can observe appear only because their light began moving across the cosmos when the universe was still very young. You are never seeing deep space all at once. You are seeing a layered conversation between ages. Keep that image nearby, because soon the light itself will begin to stretch as it crosses the expanding universe. That stretching is one of the most elegant facts in cosmology. The universe is expanding, which does not mean galaxies are flying outward through a pre-existing empty room in quite the ordinary way people sometimes picture it. It means space itself is expanding on large scales, so the distances between faraway galaxies tend to grow over time. As light travels through that expanding space, its wavelength gets stretched too. Shorter wavelengths shift toward longer, redder ones. This is called cosmological redshift, and it is one of the main reasons astronomers can tell that very distant galaxies belong to a much earlier universe. Their light has been traveling so long, through so much expansion, that it reaches us altered, pulled toward the red and often into infrared wavelengths. The oldest visible and ultraviolet light from early galaxies can arrive as infrared by the time we receive it, like a bright note lowered into a softer key during the long journey. There is a calm kind of grandeur in that. Space is not a rigid stage where everything stays fixed while actors move around. Space and time are woven together into something more fluid, more subtle. Einstein gave that woven structure a name that has become almost too familiar to sound mysterious anymore: space-time. But it really is mysterious in the loveliest way. Mass and energy change its shape. Stars, planets, galaxies, black holes, all of them curve space-time around themselves. And because light follows the geometry of that space-time, gravity can bend light. Not metaphorically, genuinely. A massive galaxy cluster can warp the path of light from even more distant galaxies behind it, magnifying and distorting their images into arcs, smears, or even luminous rings. So sometimes the universe lets one galaxy act as a lens for another, as if deep space briefly decides to become glass. That bending of light does something gentle to your sense of reality. It reminds you that the universe is not built from hard edges and straight corridors. The path from there to here may curve. The image you receive may have been magnified by gravity on the way. The light from a distant source can arrive in multiple images because it traveled along different bent routes around something massive in the foreground. It is one of those facts that sounds complicated at first and then settles into something almost soothing. The universe is flexible. The dark is not empty in the simple way it first appears. Even light has to adapt to the shape of what it crosses. Time itself also behaves with a softness that becomes more obvious near speed and gravity. According to relativity, clocks do not all agree in every circumstance. Stronger gravity slows the passage of time relative to regions of weaker gravity. Motion at very high speed affects time as well. These effects are usually tiny in everyday life, which is probably for the best because most people already feel slightly betrayed by ordinary clocks. But in the universe, they are real. Near massive bodies, time runs a little differently. Near extreme objects like black holes, the effect becomes dramatic. From far away, something falling toward a black hole can appear to slow and fade as gravity distorts both light and time. The point here is not menace, it is texture. Time is not a single flat river flowing identically everywhere. It is shaped, gently or severely, by the structure of the universe itself. And somehow that does not make the cosmos feel more chaotic. It makes it feel more alive. Space is not a cold box holding objects. Time is not an invisible metronome clicking the same for all things in all places. Both are responsive. Both are part of the deep architecture. Massive objects curve space-time. Expanding space stretches light. Great distance becomes look-back time. A telescope becomes, in a very real sense, a machine for gathering delayed truth. The more carefully you look, the more the universe reveals that its grandest features are not only stars and galaxies, but relationships between light, distance, motion, gravity, and time. And then farther still, beyond galaxies whose light has crossed most of cosmic history, there remains an even older glow, fainter, smoother, more ancient than any star, a whisper from a time before galaxies were fully assembled, before the sky had familiar shapes at all. The universe kept one of its softest lights for last. Far beyond the galaxies, beyond the young bright systems whose light took billions of years to find you, there is a softer kind of glow waiting in every direction. It does not come from stars. It does not belong to any single galaxy. It has no spiral arms, no bright core, no elegant cluster shape drifting through the dark. It is older than all of those familiar structures. It is spread across the whole sky like a hush that never fully left. This is the cosmic microwave background, often called the CMB, and it is the oldest light we can observe in the universe, a faint relic from a time when the cosmos was still very young. To feel why that is so beautiful, it helps to picture the universe before stars had begun their long, calm shining. In the earliest ages, space was hot, dense, and filled with charged particles and light all mixed together. Photons, the particles of light, could not travel freely for long because they kept scattering off free electrons, a little like trying to look through heavy fog where every beam is bounced around before it gets anywhere useful. Then the universe expanded and cooled. About 375,000 to 380,000 years after the beginning, electrons and protons combined into neutral atoms, and the fog lifted. Light could finally move long distances without being endlessly scattered. That ancient release is the glow we still detect today. Astronomers sometimes call that moment the surface of last scattering, which sounds technical, but the feeling of it is simple enough. The young universe became clear enough for light to begin a very long, very patient journey. And that light has been traveling ever since. Over all those billions of years, as the universe expanded, the light stretched with it. The wavelengths grew longer and longer, drifting out of the visible range and into microwaves. So the oldest visible light is no longer visible to your eyes. It has relaxed into something cooler, quieter, softer. Today the CMB fills the universe with a nearly uniform glow corresponding to a temperature of about 2.7 Kelvin, just a few degrees above absolute zero. That is one of the gentlest numbers in cosmology. The whole universe still carries this faint afterglow, not as a blazing memory, but as a cooled remnant, a low whisper of its brighter youth. It is as if the earliest light did not disappear at all. It simply settled down. What makes the CMB especially soothing to think about is its smoothness. It comes from every direction and is almost the same everywhere, which tells you that the early universe was remarkably uniform on large scales. Not perfectly uniform, though, and that quiet imperfection matters. When scientists map the CMB in detail, they find tiny temperature variations, minute differences spread across the sky. Those little ripples are not flaws. They are the earliest visible hints of structure, the subtle unevenness that gravity would later deepen into stars, galaxies, and clusters. So in this ancient light, you are seeing both calm and possibility together. A nearly even glow, carrying tiny departures from sameness that would one day become everything more familiar. There is something deeply comforting about that idea. The great architecture of deep space, the galaxies drifting like lanterns, the nebulae breathing light, the long calm lives of stars, even the hidden world circling in the dark, all of it grew out of incredibly small differences in an early, almost uniform universe. The magnificence came from slight variations, from quiet seeds. Deep space did not need a dramatic beginning in the emotional sense to become beautiful later. It needed time, gravity, expansion, and a little texture in the glow. The universe has always been wonderfully patient with its own becoming. And human beings on one ordinary planet around one ordinary star learned how to listen to this faint light. That is another lovely part of the story. The CMB is far too faint for your eyes, but careful instruments can detect it. Missions such as COBE, WMAP, and Planck map this glow across the whole sky, refining our picture of the early universe with extraordinary care. COBE first confirmed the CMB's near-perfect blackbody spectrum and detected its tiny anisotropies. WMAP produced a full sky map of those subtle temperature differences. Planck measured the relic radiation with even greater precision, giving us the clearest view yet of this baby picture of the cosmos. The universe kept its oldest visible light for nearly 14 billion years, and eventually a small species built tools delicate enough to notice. The image those missions reveal is strangely tender once you stop thinking of it as data and let it become atmosphere for a moment. A whole sky filled with ancient light. Not dramatic beams, not bursting color, just a faint glow everywhere, carrying the memory of a younger universe. It is the most democratic light in existence, reaching us from all directions, touching the entire sky with the same old presence. Wherever you look, north or south, above the poles or across the galactic plane, once foreground light is accounted for, the early universe is still there in the background, quietly accompanying every later thing. Even the stars do not erase it. They merely shine in front of it. And yet the CMB is not the absolute beginning. It is the oldest light we can observe directly, but there were earlier times before even that glow was free to travel. The universe held older chapters still hidden behind that first great clearing. That thought does not need to feel frustrating. It can feel peaceful instead. Deep space lets you see very far, but it also keeps a little privacy. There is a boundary to direct sight, a softly drawn veil beyond which the universe becomes harder to observe in the same way. The earliest light is available. The very first instant remains more mysterious, which is rude, honestly, but also beautiful. So when you think about the deepest dark, it helps to remember that it is not truly dark in the simple sense. It glows, very faintly, very evenly, very old. The background of the universe is not blank blackness but a cooled remnant of an ancient brightness, stretched across time until it became almost gentle enough to miss. And from that delicate glow came the quiet irregularities that would grow into the galaxies we wandered through earlier, the stars that held their long balance, the planets orbiting unnoticed around distant suns, and eventually one world where someone could lie awake under a familiar sky and wonder what the darkness really contains. It contains memory. It contains beginning. It contains a low and patient radiance that never entirely went away. And with that, the journey begins to gather itself. The stars, the dust, the silence, the galaxies, the old light, all of it starts to feel less like separate marvels and more like one long, connected calm. Only one step remains now, to rest at the edge of all this wonder and let the whole universe feel somehow close. By now, the universe has become strangely intimate. You began under a familiar sky, with stars scattered above you like quiet thoughts, and somewhere along the way those points of light opened into distances, then into the Milky Way, then into the wide hush between stars, then into nebulae, long-lived suns, hidden worlds, drifting galaxies, and that ancient background glow that still lingers from the young universe. None of it rushed. None of it needed to. Deep space has a way of drawing you forward without ever pulling too hard, as if the cosmos understands that the most beautiful truths arrive softly and stay longer that way. The farther astronomy looks, the farther back in time it sees, and the deeper the view becomes, the more the universe starts to feel less like a collection of objects and more like one connected calm. It helps, at the very end, to hold the scale of it with a lighter touch. Around 13.8 billion years have passed since the early expansion of the universe, and in that vast span, matter had time to cool, gather, glow, drift, and slowly organize itself into the structures you have been moving through tonight. The oldest light we can directly observe comes from when the universe was only about 380,000 years old, and the tiny variations in that ancient glow became the seeds of later structure. Galaxies, stars, planets, and eventually places where someone could stand under a dark sky and wonder what the silence contains. That sequence can sound enormous, and it is, but it is also remarkably gentle when you look at it as one long unfolding. And what the silence contains more than anything is continuity. The hydrogen in stars, the dust in nebulae, the drifting shapes of galaxies, the old background light stretched thin across all directions. All of it belongs to one reality that never truly broke into pieces. You divided it into stars and clouds and distances because that is how the human mind learns gently, one shape at a time, but deep space itself remains whole. A galaxy is made of stars and dust and dark matter held together by gravity. A nebula becomes stars. Stars illuminate gas and help form worlds. Worlds circle inside galaxies. Galaxies gather into larger patterns. The oldest light lies behind them all, still faintly present. The universe is not a stack of disconnected wonders. It is one long breath. That may be the most relaxing fact of all. You are not living in a random scattering of unrelated things. You are living inside a cosmos with memory. Light keeps records. Gravity shapes slow conversations across millions and billions of years. Space leaves room between things, and that room is not wasted. It is where light travels. It is where clouds gather. It is where future stars wait inside darkness. Even the great distances that first sounded lonely begin to feel generous after a while. They give everything enough space to become itself. So when you imagine deep space now, it may no longer appear as a cold, black emptiness with a few bright decorations pinned onto it. It may feel more like a vast, dimly glowing ocean of time, where stars bloom and settle, where galaxies turn with patient dignity, where even the oldest light still crosses the dark without complaint. The universe expands, light stretches with that expansion, and the earliest galaxies Webb observes appear as they were in the young cosmos, their ancient glow arriving only now after traveling for more than 13 billion years. That is not just distance. That is reality choosing to reveal itself slowly. And slowly is exactly the right speed for a universe like this. If everything were immediate, deep space would lose part of its tenderness. You would not have that lovely delay, that soft truth that every star is a little old by the time you see it, that every galaxy is sending you a portrait from another age, that the deepest glow in the sky is the aftertaste of a younger universe finally cooled into calm. Delay is built into the beauty. Time is built into the beauty. Even the facts that sound abstract at first become restful once they settle in. Light takes time. Space stretches, gravity shapes, matter gathers, structures form. The darkness keeps its secrets for a while, then gives them up in faint glimmers. And it is enough. You never need to hold all of deep space in your mind at once. No one does. The universe is too broad for that, and thankfully it does not require such effort. It offers itself in pieces. A star first, then a band of the Milky Way, then the idea that stars are far apart, then the idea that the space between them is full of thin gas and dust. Then the realization that clouds can become suns, and suns can hold worlds, and worlds can exist by the billions in one galaxy among countless others. Then the quiet astonishment that the oldest light still remains. Wonder arrives by layers, which is very considerate of it. And as those layers settle, something else settles too. The scale that once seemed overwhelming becomes strangely comforting. The age of the cosmos makes a hurried week feel less absolute. The patience of stars makes urgency feel less impressive. The silence between galaxies makes clutter seem temporary. The whole sky starts to offer a kind of emotional perspective, not by dismissing ordinary life, but by giving it room. You are still small under the universe, of course, but small is not the same as insignificant. A listening mind is part of the cosmos too. The atoms in your body were forged through the long history of stars. The light reaching your eyes enters a creature capable of turning photons into thought, distance into feeling, science into awe. That is a very quiet miracle. Deep space is beautiful on its own. It becomes even more beautiful when it is known. So rest here for a moment, right at the edge of all that wonder, where the facts remain true but no longer feel heavy. The stars are still far away. The galaxies are still drifting. The old background light is still spread across the sky. The universe is still expanding with immense patience. And yet somehow it all feels close enough now. Close not in distance but in understanding. Close in the way a long piece of music feels close after you have listened carefully from beginning to end. So let the sky stay open. Let the stars remain where they are, ancient and unbothered. Let the galaxies turn with their slow lantern glow in the unreachable dark. Let the oldest light keep crossing space, and it's barely their whisper. Let all of it be vast, let all of it be gentle. And let yourself drift a little deeper into the calm of knowing that the universe, for all its scale, is full of softness when you meet it at the right hour. The night does not ask you to solve it, it only asks you to look for a while. And now, with the journey nearly still, the words can soften too. The sky above you is no longer crowded with separate mysteries. It is one quiet field, deep and dark and faintly lit from within. The stars seem less like distant fires and more like small, steady companions placed very far apart so that the darkness between them can breathe. The Milky Way stretches on in pale silence. The hidden worlds keep circling their distant suns. The galaxies remain suspended like dim lanterns, so far away that even their brightness arrives gently. And behind all of it, older than every starry pattern you know, the first great light of the universe rests in the background, cooled into a whisper so soft that only careful instruments can hear it. You do not need to travel there. You do not need to understand every law of gravity or time or light. It is enough to feel the shape of it for a moment. A universe expanding without hurry, a cosmos keeping its memory in light, vast distances carrying not emptiness but patience, slow beauty moving through darkness for billions of years and arriving here tonight in a form quiet enough to rest beside. So the mind can loosen now. The images can blur at the edges. The facts can become atmosphere, a soft band of starlight, a hidden cloud becoming a sun, a far-off planet under a sky no one has seen, an ancient glow filling the whole universe almost invisibly, everything continuing, everything connected, everything calm. Stay with that for one more breath. Then another. Let the darkness be wide and kind. Let the stars keep their distance. Let the universe be old, quiet, and endlessly patient around you. And let the night hold the rest.